Hey guys, my name is A.V. Jagannathan and today I'll be solving this question from PayPal's online assessment for the batch 2026. So let's look at the question here. So we have to find the optimal generator string. And what is a generating string? A generator string X for string S has the following property. We can form S by taking out characters from X cross M, where M is some positive integers. Basically, you have to multiply the generator string X by a certain number of repetitions M. From that, if we take out values, we can form S. Given a string S and a number n, find and print generate a string x of length n which satisfy two criteria. Number of repetitions to form S should be minimized, and then lexicographically it should be the smallest among such strings. If no such string x exists, print 1, minus 1. So let's look at an example to understand the question better. We are given a string S which is AAB, AAB and then BA, and we have to generate a string of size 3. So basically you can see that there are 5 A's in the given string and 3 B's in the given string. If suppose we are saying the generator string should be ABB, then how many times should we have to multiply it or repeat it in order to generate the given S? Suppose we say the X is ABB, there is 1A in X and 5 A's in S, so we have to multiply it by a minimum of 5 times in order to get 5 A's, and B's doesn't matter because there are just 3 B's here and there's already 2 B's, so multiplying by 2 times will solve it. But since we need to have 5 A's, right, so we have to multiply by 5 times. And as you can see, A, and then another A. So 5 A's are satisfied and 3 B's are satisfied. There are extra characters, but it doesn't matter. We just have to, pick characters from it in order to match target. Let's take another case, AAB, and we have to multiply it by 3 times in order to generate 6 A's, which is greater than the given target, which has 5 A's. And there is 1 B here, so we have to multiply by 3 in order to get 3 B's. So AAB can cancel, and then another AAB can get cancelled, and a B gets cancelled, and A gets cancelled. There is one extra A, but it doesn't matter. So as you can see, AAB generates S in 3 repetitions, but ABB generates S in 5 repetitions. So basically, this is what we have to minimize. We have to minimize the number of repetitions. For this question, we can prove that AAB is the lexicographically the smallest thing which will be able to generate S in the least number of repetitions possible. Yeah, so for example, we cannot choose ABA or BAA because both are lexicographically larger than AAB. That we have to note down as well. So now that we have understood an example, let's look at how to solve it. First, we have to find the configuration, which is number of A's and number of B's and so on. And after finding the configuration, for example, if we say 5 A's and then 6 B's and so on, we can just multiply them like 5 A's followed by 6 B's and then just print them, because lexicographically it will be the smallest if A followed by A, B and so on, or if you want you can sort it as well. So that's what you have to do. We have to find the configuration, just number of A, B, so on and X, and later we have to sort it, and then later we'll just combine together. So how we can actually find the configuration? Well, one way to go about it is finding the ratios and then picking where the ratios. What do I mean by ratios? Well, as you can see here, A occurs almost twice as much as B, right? For example, A occurs 5 times, but B occurs only 3 times. So the ratio is 5:3. So in case you are picking one B, you want to pick 2 A's. So that's the idea here. And by doing that, you'll get AAB as well. But a problem here is that it doesn't work on all cases. For example, let's take another example. A 3 B's followed by 4 D's, and the generator string should be of size 5. The ratio between B and A is 3, and while D and A is 4. 4:1 and 3:1 basically. So we should be able to generate. That's the first thing. So we have to pick one from each of these unique characters, which is A, B and D, and still there will be 2 places yet to fill. And these 2 places we can fill it by either filling with both D or with D and B. See, if we fill both with D, then we'd have to do 3 repetitions in order to form the given S. But if we fill it with D and B, we just have to do 2 repetitions. but the ratio of D's to A is greater than the ratio of B's to A. So that arises a scenario where you have to take into account the ratio between D and B as well, and so on. When there's 26 or 26 alphabets, right, when they have to take in lot of edge cases into account, and this is a lot of hard coding, and we want to avoid that because it will take a lot of lines and a lot of time will be wasted, and it will be harder to debug as well. So what we can do instead is, we know that we have to multiply x by a given number of, x by some number of repetitions, let's say it is m right now. So we know for a fact that count of character A in x times m should be greater than or equal to count of the same character A in S. So right, in order to pick it, we can simplify this by saying count of A in x times m is basically count of A in x times m. And then we can get the count of A in x by just dividing count of A in S by m and taking the ceiling value of it. Well, but we don't know m, right? Yeah, that's the thing here. We don't know m right now, so we cannot figure out what is the count of A in x. But what we can instead do is we can iterate over the values of m. For example, let's say m is initially 1, right? Okay, sorry, my bad. Let's say m is initially 1. We can iterate from m is equal to 1 till m is equal to length of s. Why length of s? Well, within the length of s repetitions, we can obviously generate s without any problem. So we can go from m is equal to 1 till m is equal to length of s, and we'll figure out whether we can generate whether we can have a string x with m repetitions basically. How will we actually do that then? Well, we know for a particular single character A, the count in x should be this value. For that, we can do for all the characters A, B, C, D, and so on, and each of them will give a value S1, S2, or C1, C2, C3, C4, which are the counts of that particular character in x. And what we know about x should be of length n, right? X should be of length n. So the condition that these should be satisfied is S1 plus S2 plus S3 plus so on should be less than or equal to n. On that occasion, we can generate a string x. So that's the idea behind it. And thing is, since m is incrementing from 1 to n, the first m that satisfies the given condition will be able to is the solution, because we have to find the minimum number of repetitions, right? And let's look at the time complexity of the solution. It is O of n for initially finding the count of each character in S. We have to iterate over the entire string S, so it is O of n plus 26 times m, where m is the minimum number of repetitions possible. 26 because we have to do this for each character A, B, so A, B, and so on. This is already pre-computed, so count of this will take O of 1 only. And for count of finding each of the character will take O of 1. And since there are 26 characters, it's 26 times m. Right, so the solution will be O of n plus 26 times m. But this is acceptable, but this is not the most efficient solution. So how we can make this more efficient? Well, we can do a binary search on answer, and the answer here is the number of repetitions. Well, what do we do binary search on answer, right? We know that the minimum value of m is 1, minimum possible value of m will be 1, and the maximum possible value of m will be length of s, right? And suppose let's take an arbitrary element. Let's say the left hand side is L and the right hand side is R. Let's take an arbitrary middle element which is L plus R by 2, and let's call it m initially. We'll check whether under these many repetitions will it be possible to generate x of size n under m repetitions. We'll check whether it will be possible to do that in m repetitions. If it is possible to do so, then it means that we don't have to check from m plus 1 to r, right? Because obviously we need the minimum number of repetitions possible, and if m is possible, why you need to check for m plus 1, right? So we can eliminate the right hand side array on that occasion, or right hand side answers in that occasion. Well, in case what if it is not possible to generate m, not possible to generate x under m repetitions, in m repetitions. On that case, it will not be possible to generate x from anywhere from L till m repetitions, right? Because if m is not unable to generate, then m minus 1 will obviously not be unable to generate also. On that case, you can eliminate the left hand side part of the answer. So, and only take the right hand side part of the answer. By this way, on each occasion, you eliminate half of the given search space, and by doing this, we can bring down the complexity of 26 times m to 26 times log of m. And if you want to know more about binary search or answer type questions, I'll ping some links in the comment section. You can go through them. So let's take a look at the C++ solution. Initially, just getting the inputs n and s, and after that, we are just calculating the frequency of each character in s. Just using a hash map for this. You can even use an array of size 26. And I'll show you the binary search solution. If you want to do it in O of m 26 times m, then we can just replace this with a simple while loop. And yeah, initially just start with L is equal to 1 and R is equal to S dot length. And initially just say answer is minus 1, right? And we'll find for m, we'll take a particular mid element, and we'll check whether if it is possible to generate x of size n with the counts being f in m min number of repetitions. And this is just what we discussed in the algorithm. And if it is possible to do so, then we'll set the answer to be equal to mid, and we'll not go to the right hand side search space. So we'll set the right to be instantly to the left of current element, which is mid. And if it is not possible to do so, then we cannot anything on the left hand side will not be able to. So we'll set the left to be equal to left to start from the right of the mid element. And as you can see here, answer will get changed here, and if it does not get changed, then nothing is possible. So answer will stay as minus 1. On that occasion, we'll just print minus 1 and then return. So yeah, that should give us a solution. And since we know that the number of repetitions, right, we can pick characters based on it. Let's see what is this particular line is for, right? I'll just submit it without it, and let's see what happens. And as you can see here, this test case fails because my output is AN while the required output is AAN. Why is that so? Well, we can see here that even if you include an extra A here, it does not change the fact that it needs 5 repetitions in order to complete. What we need is a string of size 3. And what we're actually calculating here is the minimum count required in X, right? Minimum count of that particular character required in X for that particular number of repetitions. That's what we're calculating. We're not calculating exact number of elements. So yeah, on that occasion, there is a chance that the generator string might end up less than the size of n. So on that occasion, what we are doing is we'll just add those number of a's at the start, because it needs to be lexicographically the smallest, and this should work. Yep. So let's submit and see. And yeah, it works as expected. So let's look at the Python solution now. And initially just getting the inputs n and s, and after that we are calculating the count of each characters in s, which is just the frequency f, using this particular function. We are using a dictionary to do so, and then we are starting the binary search. We know that it should start from 1 and go till length of s, and we are initializing answer initially minus 1. And if it is possible to able to generate x of size n with the frequencies f under mid number of repetitions, under equal to mid number of repetitions, then we'll say the answer can be mid, and then we'll search in the left hand side part of the array. Left hand side part of the answer. Else we'll search on the right hand side part of the answer. So what does the check function have? The check function basically has whatever that we discussed in the algorithm. We are just adding up all the counts of elements in X if it has to be found under m repetitions. And if the sum exceeds the size n, we'll return false. And if it doesn't exceed the size n, then we'll return true. And as you can see, the answer will not get changed if all of the checks fail. So answer will stay as -1. Under the question, answer stays as -1. We'll just put -1 and return. If it doesn't form so, then we'll just add all the characters and then combine all the characters together and then print them. Well, what is this particular line then? Let's see what happens if we don't have this particular line. If we don't have this particular line, this case fails. Let's see why. We know for a fact that if we add an extra a, it does not change the number of repetitions. It will still be 5, right? If you have an or an, the number of repetitions will still be 5. What a function actually does is just calculate the minimum number of elements that are needed in X. It does not calculate it just calculates the minimum number of elements that are needed in X, right? So what happens is it might end up short of n. So on that occasion, it ends up short of n. We have to fill the remaining elements with a at the start. We have to fill the remaining elements with a at the start. And why are we filling with a at the start? Well, because it has to be lexicographically small, so we don't want any other element. And if it doesn't matter which element that we include, the answer still remains the same. So that should give us a solution. Let's see if it is accepted. Thank you, and comment down if you have any other approaches in mind.